Benjamin Cabe from Eclipse. We're back for another virtual IoT webinar. Actually, this week with lots of people from the Eclipse Foundation at Java One in San Francisco. We had lots of cool talks around Eclipse IoT, like Eclipse Smart Home and Cora and Paho, Californium, tutorial about Californium. So stay tuned for the videos, which I think will be made available shortly by the Java One team. And yeah, we're back for another virtual IoT session today with Iker from Everything, and he's going to talk about the Compose platform, which is an open source IoT platform. So yeah, without further ado, Iker, if you want to do a quick introduction of yourself and get started with this Compose presentation.
Yeah. Yes, okay, so hello everyone. My name is Iker. I work as a research developer here in Everything. Yeah, a bit of a background. Everything is an IoT company. We provide a platform to make products smart. And we've been working these years in Compose, a European research project. And I'm here to explain a bit about it and present the features and show you some hands-on on the platform. So I will just now share my screen. Okay. Okay, so I will give a very brief introduction to the Internet of Things, just some things that I want to highlight before presenting the platform. I'm sure we are all aware of this, but just in case. So we are now experiencing this Internet of Things era. So one of the things that everyone is predicting is that the number of devices is going to increase by a factor of by 2020, 50 billion, says Cisco, Gartner also 30 billion. So we are getting all these interconnected devices in the internet, and more and more we're getting these kind of platforms to be able to develop IoT applications with these devices for different domains. So when we want to build an IoT application, what are the main components that we have? So first of all, if we are talking about the Internet of Things, we have the things. When we talk about things, we usually refer about devices, smart objects with different technologies. So here we have different platforms. I'm sure we all have played at least with some of them and many more. Then on top of the things, we need the network, we need connectivity. And in this part, we have all the different standards, Wi-Fi, Zigbee, Bluetooth, etc. that are interconnect these things. And the last part, the last component we need are the services. So we have devices capable of collecting and sending data through any type of network connectivity. But the important part are the services, and these services can go from sensor data management, device management, analytics, etc. So we have these three main building blocks, so to say. Additionally, what else does it take to build an IoT application? So we can say that we are going to integrate many other different services to create our applications. So we have to be aware and search all types of libraries, be familiar with all the APIs, what type of users, etc. Additionally, if we are creating an application, we need to have some means of deploy and manage some kind of backend infrastructure. And here, okay, we have to think which software we're going to use, which hardware, what are the limitations that we have, or what type of application. And of course, on top of this, how are we going to manage and maintain this data that we are generating and using in our application? And yeah, on this topic, okay, what are the resources? How are we going to scale? How are we going to manage, etc. So all these type of problems, so to say, or issues are the ones that we have to take into account when building an IoT application. And yeah, sorry, I forgot. This of course consumes time and also money issues. So this is something that we have to consider. So on this topic, I'm now going to present Compose. So Compose takes into account all the parts, all the components that you need to create an IoT application, and tries to leverage different services and create a platform to facilitate to developers to create and build and deploy IoT applications and follow and manage the whole life cycle of them. So as I said, Compose, it's a European project. It has 12 partners from all around Europe, and it's basically a platform, scalable platform as a service for the IoT. And we are mainly providing this scalable platform. We have been focused on providing a lot of development tools that I will show you later. We have created also an IoT marketplace where users can also create services and share services for the IoT. And another piece of component is that we are based on a common object model. So this is how we are going to define the things and how they can be shared and accessed and share and used throughout all the applications. So, and this platform is open source and it's available for free, so anyone can use it and play with it. Here I present just an overview of the architecture. So basically, it's a platform as a service. So a core part of the platform is its API, and we provide an API covering the different aspects of this building application. So you will find an API for service lifecycle. You will find an API for data management. You will find an API for security, and you will find an API for all the management of the services. On top of this, we provide also SDKs, and we have a portal which defines a dashboard where you can use and compose these elements in an easier way for developers. And basically, you can see there the technologies that we are based on. So we use Apache Storm and Couchbase as the data management foundations. Then we have a security framework. We have also a semantic discovery service. And for communications, we provide common REST interfaces, WebSockets. We also have MQTT for subscriptions. And for the cloud infrastructure that we provide, we're based on Cloud Foundry. And for putting all the pieces together, we are based on Node-RED, which is a UI platform based on Node and JavaScript to create and deploy applications. So I will show you a bit more soon. So what we provide in practice? So we divide the platform in different components that the developers can use and access. So the first thing, we call it glue things, and it's the dashboard is the entry point of the platform, where you can configure your users, you can configure your security, you can create your components, deploy them, monitor them, etc. Then we have another component that we call Servioticy. This is the data management block. It also provides an API, and it's basically what enables the data collection and streaming from and to the platform. Additionally, we make use of semantic technologies to annotate the components, and then use that for either discovery or composition. And the component that takes care of it, it's called Iserv. We have a security framework that takes care of all the access control policies, user management, provisioning of tokens to be able to access the platform, etc. We have different SDKs that you can play with for different embedded platforms, for JavaScript, for Java too, which provides the SDKs to, as I said, to access the functionality. So these are the main components that are exposed, and then under the hood we have also the lifecycle management, which takes care of all the instantiation, deployment, and monitoring of the different components, which is deployed in Cloud Foundry, as I said, and Node-RED as the idea for the UI for the usage. And all these components are also available in GitHub, so you can check our website and have a look and play with them. Before going to the hands-on, I will explain a bit more each one of the components. So the first one, that is the core of the data management. As I said, we call it Servioticy, and it provides a service object abstraction. So one of the key aspects in different platforms is how you represent the things, how you represent the devices or the smart objects. So we have taken a simple approach. So we define a simple model, which we call it service object. A service object is kind of a virtual representation of anything or any device that you want to use in your application. And it defines three main things. So it defines the data that it's going to produce. And this data is organized in streams of information and channels. So we will see examples later. These service objects can have also actuations, defines the actions that we can do on them, and the subscriptions, so that we get notified when the information is updated or when certain conditions are met. And this component provides a RESTful API where you can store the device data, query and retrieve the data, push data, and subscribe to the notifications, either using REST, MQTT, or WebSockets. So on top of this, we have the glue things component, which I said is the dashboard, the entry point of the platform. It's conceptually based on Node-RED, and so it allows you, for those of you who know Node-RED, it's a collection of nodes with small programs written in JavaScript that you can easily deploy and easily debug. So with this extension, we will be able to create our service objects, create application workflows, and deploy them to the cloud so that they are monitored and they are available. We will be able to configure also from here the security, create the users, create the groups, create the policies. And in the idea of creating this marketplace of share applications and objects, we will be able also to discover and services that other users have published. The Iserv component, as I said, is the semantic discovery capabilities. It's a search engine based on annotations. You can search free text, category search, or you can create more complex queries. For those of you who are familiar with semantic technologies, it's based on an RDF store, so you can create your Sparkle queries based on the ontologies that you have used to annotate the different service objects or applications of your programs. And the part about security, so security is one of the main and biggest concerns in IoT applications, especially because you're potentially sharing information that is sensitive to the user's privacy. So we have defined a comprehensive security net framework that takes care mainly of identity management. So how to create, which are the users, how to define groups, how to create tokens to access the different objects, the different service objects. What are the privileges that these tokens have, etc. Then we enable also the creation of security policies based on those users and those groups, and even on the data, on the service objects and data streams. So this is mainly used so that you can configure who can access what streams from which objects under which conditions. And additionally, we have integrated the reputation manager. So based on how the service or how the service objects and how the applications are used, and how the monitoring, you can, and also feedback provided by the user, you can see what is the popularity of a service and what are the problems with it, and have rankings of services when you are building your own applications based on components created by others. And yeah, so this was the brief overview of the platform. So now let's go into, let me show you how it works. So the first thing you can do is go to, we have a developers portal with all the additional information of the platform and basic tutorials. And here you can go to get started dashboard. And here is the entry point. So I will start from here, which is bigger. So the first thing we need to do is to create a user. So let's register in the platform. So I will create user. I hope it's correct. Okay, so now that it's created, we can log in the system, and we will see the main part of the dashboard. Here we have a streams, which is this screen where we can configure our service objects. And here we have the composer, which is the part based on Node-RED, where we are going to be able to define our applications. So the first thing we want to do is to add a new service object or a new device. So as I said before, this is going to be the virtual representation of a thing or a device that we have that we want to use in our application. So for example, let's imagine we have a device. And then we have to define the streams. Streams are the streams define the information that the device is going to provide. So for example, let's have a stream which is sensors. And then let's have a channel which is temperature. So one feature we have here in this dashboard is that it's already linked to the option to annotate the service semantically. So we have here preloaded an ontology for sensors and devices. So we can already say that, okay, this is going to be a temperature sensor, and it will automatically populate with the values of the ontology. Of course, we can use also our own ontologies, and it will be loaded in the same way. So let's create this object. Okay, so now we have here our device, and in the dashboard you see some information that you will need for your application. So every object has an ID. So this is the unique identifier in the system. Every object has an API token that you can retrieve with your credentials. To push and retrieve data from this object, you will see here the endpoint. And here you can see the streams that we have defined. So we have defined sensors, temperature in this unit. So to push data to the platform, it's as I said, we provide an API. I will show how to. I have a very simple Node program here that has a HTTP call. So what we need to fill is the device ID, which in this case is this one. So the name of the stream, which I call it sensors. The API token, important. So to be able to write to this service, we need to use this API token. And in this case, it is displayed here because I'm logged in. But in your application, you will have to get it from the platform. And then the channel is called temperature. Okay, so now if we run this simple push script, so we see here that the channel, the value has been updated. So this way we can already start pushing information to the platform. This is a simple Node script, but if you have a device, imagine that you implement this in the platform of your choice, like I don't know, Arduino or Spark.io. So as long as they have HTTP libraries and connectivity, you can start pushing information to the platform. Another functionality that I want to show you is the ability to combine streams. So if we define another device with a similar stream, let's use also the temperature and degrees Celsius. Okay. Okay. So there is the possibility to create what we call data processing pipelines. So this is something that it's usually quite useful in IoT application, the ability to combine different streams. So in this case, we can define a data processing pipe, which eventually it will be accessed as any other service object. So the way you access it is the same, but internally it will aggregate or compute the information from other objects. So in this case, we can call it aggregation. And first, we define which service objects are we going to use, and we give them a name. So for example, all devices. And here I say, okay, I want to use my two devices. And here we establish which stream are we going to take from these devices. So as I said, I was going to use the sensors. And then we can create a new stream, which is going to be, I'm using the same type, but eventually we can combine, we can define whatever we need. And the interesting part is here that the value, we define a function. So in this case, we are saying we are just mirroring the values of the different updates into this new channel. So we are aggregating in one single stream all the updates that are being received by these other devices. And we check the same. So this is a way of aggregating data that comes from different objects. And in this case, so now if I update again the previous service object, the aggregation is already displaying the value. So this simple example can be extended to pretty much any other function that you want. For example, you can transform, as we are talking about temperature, you can transform it dynamically and automatically from Fahrenheit to Celsius, for example, or you can do some other transformations. We have an example in the website also for sensors sending location and doing this using these data pipelines. You can do geofencing, and you can filter dynamically the information that comes from certain sensors based on the location. And this is just as you saw, as easy as defining this function and combining the different flows, and they are treated as any other type of object. Okay, so the next thing I want to show you is that this is the part where we have created service objects that represent the identity of devices or things. But then we also want to build applications that use this information to do more complex things, or as we said, to connect to other systems or reuse other functionality. So this is what you would do with the composer. As you see here, this is based on Node-RED with some special nodes. So we have a node here that is for compose, and in this case, it is populated with the service objects that I already have. So as you see, the three that I just created. So for example, let's take my device, and the output of this node will be the whatever channel I select here. So I have defined just one, which is the temperature. So I will show you just where's the here. I will do a very simple test. Okay. So the first thing we've done is to define the application. So in this case, well, we don't even need this blank. So this will just force this node to push the information, which is the value of the stream temperature. Here we have the debug information. And the first thing, once we have our application ready, the first thing we have to do is to deploy it. And one second. And once we have deployed, we can actually push it to the Compose cloud to create a Compose application that will be enhanced with this monitoring and security capabilities. And for that, it's as easy as pushing this with a name. So I invite up. And now this application will go through the life cycle of the platform. So first, it will instantiate, validate, and finally, it should be up and running. Now it's deploying. And eventually, it will appear here as a different node. So if you create a more complex application combining different objects or even other systems, you can reuse it. And then it will start being monitored, and users can provide feedback. So I can show you how it would look like. So this search node, it's also connected to the semantic discovery. So you can here search based on the input of a service, or the output, or the class. Okay, so you saw there that the application has been deployed, and now we have it here, ready to be used in other flows, and it's already live and running. In this case, I don't have any endpoints or anything, so but just to give you an idea. And for example, here the search node, where I wanted to show you too, is that now we can search for objects that are registered in the system and have these conditions, either free text or based on the semantic annotations. And also integrated in the platform is this reputation and popularity of the services. So using the other APIs provided, users can give feedback, can rate them, and here, based on the activity and the monitoring, this will start creating the reputation index of the service, so that if you are creating your app, you can see comments about it in terms of components and in terms of the service. Okay, so I think yeah, I have a bit of more time to show you the links. So just a recap. We created here service objects which represent devices. Then we can already connect the devices to push information to the platform. We can create aggregations and filters based on the information that we received. To create more complex applications, we can here search, discover, and compose different flows, and we deploy them to the cloud, and they are monitored, and the security is analyzed, the reputation is built, so that the whole life cycle. And yeah, I think I'm running a bit out of time. In the slides, I have also the links to the other tutorials, and you can find also a full application in the in the portal, you can find an end-to-end application which shows how to. It's based on it's a mobile application which combines these services and explains how to have semantic discovery with security, and how to step by step how to create here other applications and deploy them from the Compose dashboard. And yeah, I think we are on time.
Thank you. So I wonder if there are any questions. I will be monitoring Twitter for the next couple minutes. Please let us know with the virtual IoT hashtag if you have any questions. Maybe I do have a question myself. Is the what's the roadmap for? I mean, are there new features that are going to be added to the project?
Yes, in the live instance that we have right now, there are some things about the security, not the security how it is handled, but how it is configured. So right now here, you have to configure the security through the API, but this will be done also through some Node-RED components where you can define, okay, the same way that here you say, okay, I'm using this stream and these channels, you will be able to define policies here to restrict the access to these objects and say, okay, only this group, or only these users, or only users with these characteristics.
Okay. And are there plans to support other protocols like, I don't know, CoAP, Lightweight M2M, and others, I guess?
For now, we focus on REST and MQTT and Stomp. So based on how it evolves, yeah, we might think to include more. But for now, CoAP was not planned to support for now.
Okay. Okay, so I'm trying to see if there are other questions. And in terms of data processing, so you mentioned well, the Sparkle, the way to query the data using Sparkle, and is that part of the platform as well to actually be able to do some big data analysis and to schedule some jobs to actually do machine learning and stuff like that, or?
No, in principle, you can push the information, get notifications, you can aggregate as I shown, you can do some filtering, but if you want to do more intense data analysis, you could create the pipe from the application, sorry, from the composer, you could create easily connectors to some other data analysis platforms.
The pipe being either an MQTT channel or a WebSocket?
Yeah, exactly.
Yeah, okay, so yeah, you can, well, actually, I think, I'm not sure I've been probably blogging about it, but I have this quick tutorial on how to use the Spark streaming API for with the MQTT binding, so you can easily inject an MQTT stream into your Spark cluster and do machine learning and stuff. That's yeah, something that's actually pretty easy to do. So okay, I don't see other questions at the moment. So will you be posting your slides on SlideShare or something?
Yeah, I can post them there, or I can share the link to, yeah.
Yeah, okay. Well, I mean, anyways, the webinar is going to be online right after we end, right? It's going to be available on YouTube. So let us know if you have any questions. If you do comment on the video, we will forward your questions to ICARE and make sure they get answered. One last thing I wanted to mention. So I think we will be back on November the 2nd for our next virtual IoT meetup. I don't think the description is on the website just yet, so just stay tuned. And the thing I wanted to make sure that you guys were aware of is this Open IoT challenge that we announced at the beginning of the week. The idea is we want you guys to build cool IoT projects on top of open source software using Eclipse IoT technology, but you could also use the Compass platform. You could use Arduinos, Raspberry Pis, all the hardware that you think is relevant to build your home automation solution, your car tracking solution, etc. And yeah, we ask you to apply before November the 23rd. Applying meaning describing what's your idea. And if we like your idea, we will send you a gift card to buy some hardware to actually build the solution. And you will have until end of February next year to actually build the solution. And if you're on the final podium, you get to win lots of cool prizes, licenses for some embedded Java IDs, some hardware. You can come to EclipseCon next year, and last but not least, you can have $1,500 worth of gift certificate to buy even more IoT gadgets. So I hope you guys will be entering. It should be all pretty straightforward. Like there's this form that you need to fill in with your details. The website is iot.eclipse.org/open-iot-challenge. So I hope to see many of you guys participating to this challenge. And yeah, with this, I don't see any other questions. So Iker, thanks again. I hope we will get a chance to meet in the near future, maybe. And yeah, thanks all. See you again in 2 weeks' time. Was it 2 weeks? Yeah, November the 12th. That will be in 2 weeks. Thanks. Bye-bye.
Okay. Thank